Hello everyone, this is Shyam Babu, Assistant Professor, Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad. Today we are going to discussing about the lecture should be on modulation index and analysis on amplitude modulation. First we are going to discussing about modulation index, nothing but what is modulation index in AM and what are the different types under the modulation index. Go for the first one. What is modulation index? It is defined as the ratio of amplitude of the message signal and the carrier signal. Observe here the ratio of amplitude of the message signal and amplitude of the carrier signal. It is also defined likely. It is the ratio of the maximum amplitude of the message signal. Observe here the maximum amplitude of the message signal is nothing but AM is the representation of the maximum amplitude of the message signal. Here M of t is nothing but the mathematical representation of the message signal, and the carrier signal amplitude should be of AC. This is maximum amplitude of the carrier signal and it is C of t. And observe here, as discussion follows with the previous class, the message signal mathematically represented AM cos omega mt. Here AM is nothing but a amplitude of the message signal, omega m is nothing but a 2 pi fm, it is the frequency of the message signal. Likely, go for the carrier signal representation mathematically. C of t is equal to AC cos omega ct. Here AC is maximum amplitude of the carrier signal and omega c is equal to 2 pi fct, where fc is the carrier frequency. Observe the two mathematical conditions. AM is message signal maximum amplitude of the message signal, and AC is maximum amplitude of the carrier signal. And observe the definition of modulation index. It is representation of the modulation index should be either mu or m or MA. It is equal to maximum amplitude of the message signal AM and the maximum amplitude of the carrier signal AC. It is called as a modulation index. Nothing but once you know the maximum values of the amplitude values of the message signal as well as carrier signal, then it is very easy to find the modulation index. That's why the definition clearly explains the modulation index is the ratio of amplitude. Remember, we are discussing about the amplitude modulation under this. That's why the amplitude of the message signal and the amplitude of the carrier signal, that is called as a modulation index. The another name for modulation index is a depth of modulation. It is also modulation index. That's why here clearly explains one can easily calculate when the modulation index when the amplitudes of the two signals, here the two signals are nothing but one is message signal and the second one is carrier signal. Once you know the amplitude of the message signal AM value and once you know the carrier signal amplitude, for example, if you know the message signal amplitude should be 4 volts, AM is equal to 4 volts, and if you know the AC value, for example, AC value should be 2 volts. Then tell me what is the mu or M is equal to AM value is 4 by AC value is 2. This value should be equal to 2. It is called as a modulation index. Then go for the next one. You can find the modulation index for amplitude modulated wave. You know very well the definition of the amplitude modulation is the amplitude of the high frequency carrier signal is varied according to instantaneous values of the message signal. Here the instantaneous means amplitude of the message signal. It is called as a amplitude modulation. Again I repeat, amplitude modulation is defined as the amplitude of the high frequency carrier signal is varied according to amplitude of the message signal. It is called as a amplitude modulation. And observe the waveform for amplitude modulated signal. Here, for example, if you take, otherwise I am taking positive side as well as negative side. Here this is the message signal m of t, and observe here this is the carrier signal. That means here this is internal, this is the c of t. Here this is nothing but combination of AM and AC. Here also AM and AC. Based on this AM and AC, we are calculating the modulation index value. Observe here, we can also determine the modulation index with the help of modulated wave. Here the modulated wave, it is related to amplitude level. That's why we are taking here amplitude modulated signal. This is the amplitude modulated signal. Amplitude modulated signal. Observe here, I am considering A maximum to be the maximum amplitude of the modulated signal. Therefore, this is the maximum value that should be equal to A maximum, and A minimum to be the minimum amplitude of the modulated signal. That means here, for example, this is the minimum level of nothing but this is A maximum and this is A minimum. Therefore, A maximum is achieved if cos omega mt is equal to 1, nothing but maximum value. Therefore, this is the maximum voltage I am taking. That's why cos omega mt is equal to 1. A maximum is given by, what is the A maximum? Observe here, this is the A maximum. Here message signal amplitude is there as well as carrier signal amplitude is there. That's why AC plus AM, it is nothing but a maximum value. Remember it. Here how I am taking, this is the A maximum value. What is the A maximum? A maximum is nothing but maximum amplitude of the message signal is there. The carrier amplitude is also following with the maximum amplitude of the message signal. That's why AM plus AC, it is the maximum amplitude of the modulated signal. Likely, what is the minimum achievement? Observe here, A minimum is the achieved if cos omega mt is equal to -1. Therefore, negative side. Therefore, here also this is the negative value and this value should be equal to AC minus AM. This positive side AC plus AM and the negative side AC minus AM. If you take, this is the equation 1 and if you take, this is the equation 2. Just remember here, the maximum amplitude A maximum should be equal to AC plus AM and minimum should be equal to AC minus AM. Then go for third one. Here I am adding the 1 and 2. What is the first equation? Observe here, A maximum is equal to AC plus AM. This is the first equation. And what is the A minimum? A minimum is equal to AC minus AM. This is the second equation. If I am adding 1 plus 2, what is that? A maximum plus A minimum. That is A maximum plus A minimum, nothing but AC plus AM plus AC minus AM. Therefore, plus AM and minus AM get cancelled. What is this? A maximum plus A minimum is equal to 2 into AC. A maximum plus A minimum is equal to 2 into AC. From this equation, AC is equal to A maximum plus A minimum by 2. This is the equation I am getting when you are adding first equation and second equation, nothing but A maximum value plus A minimum value. Similarly, if you subtract 1 minus 2, nothing but A maximum minus A minimum. Therefore, AC plus AM minus AC minus into minus plus AM. Therefore, observe here, A maximum minus A minimum is equal to AC plus AM. This is the value of A maximum minus A minimum value AC minus into minus plus AM. Here plus AC minus AC get cancelled. The remaining should be equal to 2 into AM. From this one, AM is equal to A maximum minus A minimum by 2. A maximum minus A minimum by 2. Therefore, you know the AC value and you know the AM value. You know the AC value and you know the AM value. If observe here, as per the definition of the modulation index, we know the modulation index definition. The maximum amplitude of the message signal to the maximum amplitude of the carrier signal. Otherwise, the ratio of the amplitude levels of the message signal and then carrier signal. Amplitude levels of the message signal and carrier signal is known as modulation index. Then observe here, the carrier amplitude should be equal to A maximum plus A minimum by 2 and message signal amplitude should be equal to A maximum minus A minimum by 2. If you taking the ratio between these two, nothing but AM by AC. AM by AC as per the definition of the modulation index. Observe here, AM should be A maximum minus A minimum by 2. AC should be A maximum plus A minimum by 2. Then observe here, this one and this one get cancelled. What is the remaining? Thus the modulation index is given as mu is equal to A maximum minus A minimum by A maximum plus A minimum. Very important formula for calculating this parameter in amplitude modulated related problems. What is that? The modulation index mu is equal to A maximum minus A minimum by A maximum plus A minimum. Then go for the next one. What are the different types of modulation index? Up to now we discussed about what is modulation index and finding the maximum amplitude of the message signal and carrier signal ratio. Then that should be equal to mu or m is equal to A maximum minus A minimum by A maximum plus A minimum. Then right now, based on this means the amplitude levels of the carrier signal and amplitude levels of the message signal, that is the based on this, there is 3 types of modulation indexes. What are those? The first one is perfect modulation index, second one is under modulation index, and third one is over modulation. What is perfect modulation? It is also called as critical modulation index. Then one by one we learn what is perfect modulation. Observe here, the perfect modulation index is nothing but the maximum amplitude of the message signal and the maximum amplitude of the carrier signal, both the values are equal, nothing but equal amplitudes of the maximum amplitude of the message signal as well as the maximum amplitude of the carrier signal. That's why here AM is equal to AC. What is that? AM is equal to AC. That means perfect modulation occurs when the maximum amplitude of the message signal is exactly equal to maximum amplitude of the carrier signal. Maximum amplitude of the carrier signal. That's why AM is equal to AC. What is the meaning of maximum amplitude of the message is equal to carrier amplitude? Means, for example, if you take the maximum message signal, that message signal maximum amplitude AM is equal to 4 volts. Likely, I am taking carrier maximum amplitude is also equal to 4 volts. Then the definition, as per the definition of modulation index, mu or MA, AM by AC 4 by 4. Therefore, this value is 1, nothing but AM is equal to AC. AM is equal to AC. This is called as a perfect modulation, nothing but the amplitude of the message signal and amplitude of the carrier signal both are equal. Therefore, on that situation, what is the modulation index? The modulation index value should be m is equal to 1. M is equal to 1. Therefore, next point is the modulation index is also known as modulation depth or depth of modulation. The perfect modulation has a modulation depth of 100%. 100%. Therefore, because both are equal, 100% of modulation index we achieved when amplitude levels of the message signal as well as amplitude of the carrier signal both are equal. And in perfect modulation, what is that? In perfect modulation, the carrier level falls to 0. What is the meaning of carrier level falls to 0? Observe the waveform for the perfect modulation scheme. Observe the carrier amplitude is varying with respect to message signal amplitudes when the carrier is falls to reach to 0 level. Observe here, it falls to reach to 0 level. That is the meaning. In perfect modulation, the carrier level falls to 0. The perfect modulation causes no distortion. That is the most important. In the case of critical modulation technique, there is no distortion because both the amplitudes are equal. Just observe here, there is no distortions when the carrier amplitudes are reaches to 0 level. Reaches to 0 level. This is the perfect modulation. Go for the next one is under modulation. What is the meaning of under modulation here? The maximum amplitude of the message signal is less than the maximum amplitude of the carrier signal. The maximum amplitude of the message signal AM is less than maximum amplitude of the carrier signal. That is, if you take the otherwise, the given carrier amplitude should be more. For example, if you take the given carrier should be taking the amplitude levels of more. For example, here if the message signal maximum amplitude is 2 and maximum amplitude of the carrier signal is 4, this condition is true. The 4 is greater than 2 here. Therefore, observe here, what is the definition of the modulation index? AM by AC. AM value should 2 and AC value is 4. Therefore, this should be, observe here, 1 by 2 nothing but 0.5. 0.5 means it is less than 1. Therefore, MA should be less than 1 means the modulation index value should be less than 1. It is called as a, the modulation index value is less than 1. It is called as a under modulation. It is called as a under modulation. What is the meaning here? Carrier amplitude should be more comparing with message signal amplitude. What happens? What happens when carrier amplitude is more comparing with message signal amplitude means expecting, observe here, the under modulation has modulation depth of less than 100%. In under modulation, the carrier level falls above 0, no distortion. Then we'll explain with the help of waveform. Observe here, this is the under modulation. The carrier signal is varied with message signal, then it reaches to 0. When it falls to 0, then observe here, it's not completely 0 because having certain amplitude, it's not equal. Both amplitudes are not equal. That means what is MA is less than 1, nothing but the carrier signal having certain value, it's not equal to 1. That's why there is no distortion, but here observe, when falling to 0, it does not reaches to the 0 level. It does not reaches to the 0 level. What is the reason is AM is less than AC. Otherwise, MA is less than 1. MA is less than 1. This is called as a under modulation. Go for the next one is over modulation. as per the scene of the first one, in the case of perfect modulation, MA is equal to 1, nothing but AM is equal to AC. In the second case, under modulation, MA is less than 1, nothing but AM is less than AC. Third one, it is called as a over modulation. What is that over modulation means? MA is greater than 1, nothing but AM by AC is greater than 1, nothing but AM is greater than AC. AM is greater than AC, nothing but the message signal amplitude should be greater than carrier signal amplitude. Here I am taking simple example. If I am taking message signal amplitude should be 4 volts and carrier signal amplitude should be 2 volts, then as per the definition of modulation index, AM by AC 4 by 2, nothing but 2, MA is greater than 1. It is called as a over modulation. Observe here, over modulation occurs when the maximum amplitude of the message signal or modulating signal is greater than the maximum amplitude of the carrier signal. We know very well the another name for message signal is modulating signal. Then AM is greater than AC. Practically, I am explaining here. If the message signal maximum amplitude is 6 volts, nothing but this is AM, and carrier signal maximum amplitude is 4 volts, nothing but this is AC. Then the ratio of modulating signal amplitude 6 and carrier signal amplitude 4, and this value should be equal to 1.5. 1.5. Tell me, this value should be greater than 1. This value is greater than 1 means the modulation index value should be greater than 1. That is the meaning over modulation. The modulation index value is greater than 1. That is called as a over modulation. And observe here, the over modulation has modulation depth of greater than 100%. In over modulation, the carrier wave experiences 180 degrees phase reversal. Very important. 180 degrees phase reversal where the carrier level falls below the 0 point. Where carrier level falls below the 0 point. It is clearly explained once you see the waveform. Here it reaches to 0 level, then here 180 degrees phase shift will be happening. Observe here. Observe here. Then what happens? 180 degrees phase shift is occurs, phase reversal is happening in the over modulation. What happens means, observe, over modulation causes a severe distortion of the waveform of the message signal, which results data loss. This is over modulation scheme. Nothing but over modulation is one of the reasons why amplitude modulation is no longer used to transmit high quality sound signals. At the transmitter, limiters are included which prevent more than 100% modulation. Therefore, certain amount of data losses happens in the case of over modulation techniques. Okay, what we are discussing in today's class? In this lecture, we discuss about what is modulation index and the types in the modulation index. In the next topic, we discussed about analysis on AM generation methods, nothing but single tone AM and double tone AM. Like this, these topics can be discussed in the coming sessions. Thank you very much.